Open your fridge right now and pull out everything that is already technically rotting. The yogurt, the cheese, the beer, the sourdough bread, the kimchi, or the pickles, or the jar of something at the back that you have been meaning to finish. The wine, the soy sauce, the vinegar. Every single one of those things is, by any precise biological definition, decaying. Something is eating them. Microorganisms are breaking them down, converting their sugars and proteins into acids and gases and alcohols, changing their texture, their smell, their taste, their chemical structure. You keep this controlled decay in your home on purpose. You seek it out at the store. You are, in fact, having it for dinner tonight. And the reason goes back much further than you might imagine. The question is not why our ancestors learned to ferment food. The question is why they were already wired to love it before they ever understood what fermentation was. Because the taste we call sour and the deep savory richness we call umami are not accidental pleasures. They are sensors. They evolved to detect exactly one thing: that controlled, safe rot. The kind that saves you versus the chaotic, dangerous kind that kills you. Your tongue has been running this test for millions of years. You just did not know what you were checking for. To understand what fermentation actually solved, you have to stand inside the problem it solved. Pull something away from your current life. Not the fridge this time, but everything the fridge represents. Not just cold storage, the entire concept of preserved food. Now imagine this. You are living roughly 10,000 years before cities exist. You are somewhere in what will one day be called Africa, or the Middle East, or Asia. But the geography is irrelevant because the problem is universal. Your group has just made an enormous kill, a large animal. Hundreds of kilograms of meat, more than your group can possibly eat in a day. In a world with refrigerators, this would be a celebration. In this world, you have somewhere between 1 and 3 days before most of that meat is inedible and dangerous. The summer heat is already working on it. Flies have arrived. By tomorrow, sections of it will smell wrong in ways that every instinct in your body is screaming about. By the day after, eating it could kill you. You cannot save it. You cannot slow the process. The only tool you have is fire. And fire is for cooking, not for preserving. Everything you cannot eat today will be gone. And this was not an occasional problem. This was the permanent structure of life for most of human history. Abundance spoiled before it could be used. Want came between each abundance. The gap between having enough and having nothing was measured in days, and rot was the clock. So people watched the food go bad, and somewhere along the way, they noticed something that did not make sense. Not all of it went bad the same way. Some of it went wrong, gray and soft and smelling of danger. But some of it, under specific conditions, went somewhere else. It soured. It fizzed slightly. It smelled sharp but not threatening. It tasted different. And crucially, it did not make them sick. In fact, it lasted far longer than the fresh version. Something was happening that was not simply decay. Something in the food was fighting back. What was actually happening requires a short detour into biology that is best understood as a war. When food is exposed to air, it is immediately colonized by whatever microorganisms happen to be nearby. Most of these are competitors, each trying to consume the nutrients in the food as fast as possible, producing waste products as they go, some of which are toxic to humans. This is standard rot. It is chaotic, it is fast, and it is dangerous. But certain organisms, particularly the bacteria that produce lactic acid as they feed, play a different game. They acidify their environment as they eat. They lower the pH of whatever they are growing in, and that acidic environment kills most of the competition. The food becomes too hostile for the dangerous organisms and too acidic for the chaotic ones. The lactic acid bacteria win the war, crowd out the dangerous organisms, and in winning, they produce a food that is chemically preserved, nutritionally dense, and safe to eat long after the original ingredient would have killed someone. Fermentation is not just controlled decay. It is one set of microorganisms winning a fight on your behalf. This is why sour tastes the way it does. The sourness you detect when you eat yogurt or pickled vegetables or sourdough bread is lactic acid. It is the chemical signature of bacteria winning that fight. And a paper published in the Proceedings of the Royal Society B in 2022 traced the evolutionary history of our ability to taste it. The researchers found that genes encoding receptors for lactic acid evolved in our primate ancestors somewhere between 7 million and 21 million years ago. Around the same time, our ancestors were spending more time on the ground and relying less on fresh fruit and more on whatever food was available. Our ancestors who could detect safe fermentation, who found the sour, acidic smell and taste appealing rather than alarming, ate more of the right things and fewer of the dangerous ones. They survived more winters. Their preference got passed on. The same paper noted something that should make you reconsider every fermented thing you have ever enjoyed. A fondness for sour, combined with a sensitivity to the deep, savory richness called umami, may have predisposed our ancestors toward eventually taking control of the fermentation process itself. Umami, the fifth taste, detected by separate receptors on your tongue, signals protein. But it is not strong in fresh meat. It intensifies as meat ages and breaks down, as proteins are converted into amino acids and glutamates. The taste we associate with aged cheese, with fish sauce, with deeply savory broth made from long-cooked bones, is the taste of protein in the process of fermentation and breakdown. Our tongues were calibrated to seek it out specifically because it signaled that something dense with nutrition was accessible in a form the body could actually use. The sensors came before the technology. The love of sour and umami came before anyone understood what bacteria were, before anyone could name the process they were running. The tongue was already looking for it. The knowledge of how to reliably produce it took longer. The earliest direct evidence of intentional fermentation comes from a burial site in Israel called Rakefet Cave in the Carmel Mountains near Haifa. In 2018, a team led by Li Liu from Stanford University analyzed 3 stone mortars found at the site, which had been used by the Natufian people, a semi-nomadic culture that lived in that region roughly 13,000 years ago. The mortars contained residues of wheat and barley starches that had been malted, mashed, and fermented, the basic steps of brewing beer. The Natufians were not farmers. They did not yet grow grain in any organized way. And yet, they were already, at least occasionally, fermenting it into something that required them to intentionally process a raw material through a sequence of steps to reach a drinkable result. The oldest brewery we have ever found was built inside a cemetery by people who buried their dead with fermented grain, as if they understood that what they were doing carried a weight worth marking. Around the same time, on the other side of the known world, different people were figuring out the same thing.
The archaeologist Patrick McGovern at the University of Pennsylvania, who has spent his career tracking down the chemical signatures of ancient fermentation, analyzed residues from early Neolithic pottery found in China near the Yellow River, and found evidence of a fermented drink made from rice, grapes, and honey dating back roughly 9,000 years. Similar evidence has turned up at Göbekli Tepe in what is now southeastern Turkey, one of the oldest known monumental sites on Earth, built around 12,000 years ago, where large stone basins suggest the production and communal consumption of fermented grain. The people who built the first great gathering place of the ancient world may have organized around the act of fermentation. The feast and the brewery may have come before the temple. What fermentation did for food preservation was not obvious from the inside. Nobody understood the mechanism. Nobody knew about bacteria or lactic acid or pH.
What they knew was observation. That meat rubbed with salt and left in certain conditions lasted longer. That grape juice left in a clay vessel became something that did not spoil. That milk kept in a stomach pouch, which happened to contain wild rennet from the stomach lining, turned into something firm and edible for months. That grain soaked in water and left for a few days began to fizz and transform in ways that produced something both nourishing and disorienting. The first fermenters did not have a theory. They had the results, and they had tongues that told them the results were good. The tongue ran the experiment first. The understanding came thousands of years later. Consider for a moment where this knowledge lives today. Kimchi, the fermented cabbage eaten across Korea for thousands of years, is built on the same lactic acid bacteria doing the same work they did in Rakfet Cave.
The sourdough starter in some bakeries alive today contains wild yeast cultures maintained through daily feeding for decades. A living chain of fermentation that some bakers will tell you has been going for generations. Traditional cheese making in small European farms still operates on local wild bacteria, whose specific character comes from the particular microenvironment of the aging room, a community of organisms shaped by a specific place, maintained over centuries. The German soldiers who survived long winters in the 16th century on sauerkraut were eating the same lactic acid fermentation that the Natufians were running in a cave 13,000 years ago. The scale changed, the process never did. What changed slowly was understanding. For most of human history, fermentation was managed through tradition, through apprenticeship, through careful observation of what worked and what did not. You did not know why, you knew how.
You knew to add a piece of yesterday's bread to today's dough. You knew which vessels made the best wine. You knew to salt the fish before the smell changed, not after. You knew the smell of something going right
and the smell of something going catastrophically wrong. And you knew these things in your bones before you knew them anywhere else. Louis Pasteur, working in his laboratory in Paris in the 1850s and 1860s, finally gave the whole thing a name and a mechanism. The story of how it started is smaller than you would expect. In 1856, a manufacturer in the French town of Lille came to Pasteur with a problem. His distillery kept producing batches of beet juice that went sour instead of fermenting cleanly into alcohol. He could not explain it. He could not stop it. He wanted to know what was going wrong. Pasteur looked through a microscope at the failed batches and found living organisms he did not find in the successful ones. He then looked at the successful batches and found different organisms in greater numbers. The sour batches and the clean batches were not both failing in different ways. They were both succeeding, but in different directions. Each was the product of a different set of living microorganisms doing their specific work. This was not what anyone expected. The dominant theory at the time, championed by some of the most respected chemists in Europe, held that fermentation was a purely chemical process, triggered by the breakdown of organic matter through contact with oxygen, with no living organisms required. Pasteur's microscope demolished this. He demonstrated through a series of increasingly careful experiments that fermentation was the work of specific living things, that different organisms produced different results, that you could encourage some and destroy others, and that controlling the organisms meant controlling the outcome. He demonstrated that fermentation was not something that happened to food. It was something living things did to food, on purpose, for their own reasons. And humanity had been both benefiting from and directing this work for thousands of years, without knowing who was doing it. Now open your fridge again. Look at the yogurt. Look at the sourdough. Look at the cheese or the beer or the vinegar. None of those things exist by accident. Each one is a solution to a problem that nearly every human being who ever lived had to solve, which was how to take something that would spoil within days and make it last through the winter. Each one is a product of millions of years of taste evolution and thousands of years of practical knowledge, maintained through tradition and observation and the slow accumulation of craft across generations who understood the results long before they understood the process. Your tongue has been running this test for as long as your species has existed. The sourness you detect in a piece of sourdough bread, the deep, savory pull of aged cheese, the slight acidic fizz of a glass of wine. Those are not arbitrary pleasures. They are ancient senses doing an ancient job. The same job they were doing long before the jar, long before the cave, long before the mammoth was killed and the clock of decay started running. The test has always been the same. Is this the rot that helps or the rot that kills? And almost every time, for thousands of years, the answer came back the same way it still does now. Go ahead. This one is safe to eat.